So that's the reason why business owners are adopting to use UPS with battery banks to make sure there's no disruption to their business operations. Okay, so for battery storage, right, it can be adopted in various types of applications such as ESS, data centers, portable devices, and electric vehicles. So these are the places that you can find lead acid batteries. Okay, in this chart showing the different types of batteries, comparing the specific power versus the specific energy. From left to right, you have a supercapacitor, lead acid, nickel cadmium, nickel metal hydrate, lithium ion, sodium nickel chloride, and lithium metal polymer. Now, just talk a little bit about some of the batteries. Okay. Now, supercapacitors on the left here, the most left here, supercapacitors can operate for a long period, up to 20 years. It has the ability to handle high current value, is high efficiency, has a wide voltage range, wide temperature range, and long operating cycles, ease of maintenance. Now, the drawback is that the oldest rechargeable battery systems. Now, lead acid is rugged, is economically priced, it has a low specific energy and limited cycle count. Lead acid is used for wheelchairs, for golf cars, emergency lightings, and UPS. However, lead is toxic, so it cannot be disposed in landfill. Okay, next we have nickel cadmium. It's used where long service life is required. It has high discharge current. Extreme temperatures are required. This is the most rugged and enduring battery. Now, the main applications are basically power tools, medical devices, and UPS. All right, then we have nickel metal hydrate, which serves as a replacement for nickel cadmium, as it has only mild toxic metals and provides higher specific energy. Okay, it's used for medical instruments, for hybrid cars, for industrial application. Now, it's also available in AA and AAA cells batteries for consumer usage. And then we have sodium nickel chloride. It has a long cycle life, 15 years or more, higher specific energy, it's maintenance free, high recyclable of the raw materials, and zero emissions. So the main application is basically for electric vehicles, hybrid electric vehicles, and distributed renewable generators and grid support. So last, we have the lithium ion, which is which can replace many applications that were previously served by lead and nickel-based batteries. Now, due to the safety concern, lithium ion needs a protection circuit. Okay, it's more expensive than most other batteries, but the high cycle count and the low maintenance reduce the cost per cycle over many other chemistries. So today we'll just talk about lead acid battery. Okay, so lead acid battery, if you consider cell voltage, right, is about 2 volts. Okay, but it's able to deliver hundreds of current ampere, so it can deliver very high current. Okay, and then also lead is abundant and cheap. Okay, and it's mostly widely used for rechargeable battery. And don't forget that lead acid battery is also recyclable. Okay, very recyclable. So you can use it for second applications. Okay, so now I shall talk about the operation and types. Okay, so for lead acid, right, we have two types. First is the vented type, and the second type is the valve regulated lead acid. Now, I shall talk about VLA first, vented lead acid battery. It's also referred to as the wet or flooded battery, okay, where you have a liquid electrolyte or a vented cells where the gases produced through overcharging are vented directly to the atmosphere. So that's the reason why it's called vented. Now, these type of batteries are usually installed on open racks in dedicated battery rooms that have dedicated ventilation system. So you must have ventilation for such battery because it emits out toxic gases. Okay. Now, the two versions of VLA types where the flooded batteries lose water can be replenished by refilling with water. Okay. The second type does not need refilling due to the use of calcium plates to improve on the resistance to corrosion. So no excessive gassing also. and less water usage and lower self-discharge for the second type of VLA batteries. Now, the VRLA, or the valve-regulated lead acids, are commonly known as sealed lead acid battery. Now, this type of batteries tends to not to sulfide or degrade as easily as the wet cells, the VLA types. And they are regarded the safest lead acid battery to use. Now, there are two main versions. The first is the AGM, or the absorbed gas mat. And the second one is the gel cell, or the jellified electrolyte. Okay, that's the second one. Now, when we talk about VLA, right? So there are three versions to VLA. The first is the SLI. That is commonly used in automotive. Now, SLI stands for starting, lighting, ignition. Okay, this kind of battery is economical and provide a good level of current at low cost, but it has a short life cycle. The discharge depth is not as great, not greater than 10 to 20%. Now, the second type of VLA is what we call the traction battery, and these are mainly used in heavy industrial electrical applications such as forklift, trucks, electrical tractors, large industrial cleaning machine. Okay, these are designed for applications where deep discharge occurs. Now, the third type is called the stationary batteries, and this is used in switchgear substation, power generation, microwave relay sites, telecommunication, solar PV, oil and gas. Okay, they have a long useful life and very low maintenance is required for such batteries. So I will mention again on the two versions of VLA types where the flooded battery lost water can be replenished by refilling with water, right? Now, the second type does not need any refilling due to the use of calcium plates to improve the resistance to corrosion. Okay, this is what I mentioned previously. Now, the next one is called the valve-regulated lead acid, or what we call the VRLA. Okay, this is commonly known as sealed lead acid type. Okay, this will emit gas during charging, but because the VRLA incorporates a mechanism in which the gas is made to react with the battery negative electrode, and then it converts the gas back into water. Okay, because it is sealed, right? The water cannot evaporate, so it's contained inside there. Okay, that's what makes it safe. Now, based on the two types, we have the AGM and the gel type. Okay, the AGM batteries features a fiberglass mesh between the battery plates, which serves to contain the electrolyte and separates the plates. So it has a better self-discharge characteristic over the temperature range. Now, the gel battery use the jellified electrolyte, where the sulfuric acid is mixed with the fumed silica, which makes the resulting mesh gels like a gel-like and immobile. Now, the gel battery reduces the electrolyte evaporation, spillage, and this will lead to less corrosion problems, okay, which is very common for the wet cell battery, and this will boost the greater resistance to shocks and vibration. So due to the construction, the gel and AGM type of VRLA can be mounted in any orientation and do not require constant maintenance. So you can put sideways, upright, but not upside down. Okay, you cannot put it upside down. So then I'll talk about the degradation. Now, all batteries are affected by self-discharge. Okay, it is permanent and cannot be reversed. So self-discharge increases with age, number of cycles, and elevated temperature. Okay, lead acid has a high self-discharge rate of about 0.5% to 1% per day. Now, there are three ways of self-discharge which can happen to a lead acid battery. The first is H2O electrolysis, which occur due to potential difference between the positive and negative electrode. And this will cause a power consumption and voltage drop. Now, potential difference in the water decompose into hydrogen and oxygen, right? Now, the second type is the electrolyte and electrode reaction, whereby sulfuric acid in the electrolyte reacts easily with the metal in the electrode, causing voltage drop. Okay, that's for the second one. Now, the third one is due to impurities, where the ions in the water oxidize more easily than lead, okay, reacting with the electrode, especially for those ions, leading to a drop in performance. Now, it is necessary to replace with purified water to replace to reduce the impurities. Okay, next. So for chemical degradation, it actually produces irreversible reactions that cause the battery to gradually degrade. The discharge causes the lead in the electrode to become lead sulfate. Okay, but when this happens, right, it develops a stable crystal structure over time, what we call sulfation. Now, since lead sulfide becomes less conductive once it crystallizes, it will not revert to lead, even if the battery is charged. When lead sulfide crystals adhere to the surface of the negative electrode, the reaction area becomes the electrode and the electrolyte decreases, causing the internal resistance of the battery to increase. Also, the concentration of the electrolyte decreases, causing a voltage drop. Now, the fall of active material, basically the lead dioxide and the positive knots, is packed in pores of a grid. So loading and unloading deforms the grid. So the battery capacity decreases as the material will not return to its original state. Then come to maintenance. So why do we need to test and carry out maintenance routine for lead acid backup batteries? Now, if the current status of these backup batteries in major installations are unknown, then we will not know if the backup system is reliable, right? So if you want to avoid any unforeseen power failure or stoppages, then it is important to test out to ensure that the backup is reliable. Now, another good reason to test the battery is that companies will face capital loss if batteries are replaced sooner than necessary. So it's important to test these batteries to determine which batteries need to be replaced. So that's the reason why we measure the batteries. Companies need to know what to do in order to extend the battery life, and then need to find the optimal replacement time. So to keep the lead acid battery in good condition, okay, apply a fully saturated charge lasting 14 to 16 hours. If the charge cycle does not allow this, then give the battery a fully saturated charge once every few weeks. If at all possible, operate at moderate temperature and avoid deep discharge. So charge as often as you can. Okay, that's one way to extend on the useful life of the battery. Now, when it comes to capacity test, right, this is what we call like a DCIR test. So this is one way to analyze the health indication of a battery. Now, the traditional charge, discharge, and charge cycle is still the most dependable method to measure battery capacity. But the entire process can take up to 4 days, which is very time consuming, and the whole process is very expensive. Okay, so for the IEEEs, they specify the frequency, but generally every certain period of years, let's say 3 to 5 years, is a good span for the battery life. Okay, so then we have ACIR testing to test on the internal resistance of batteries to judge the health state with reference to the manufacturer specs. So naturally, as the number of charge and discharge cycles increases, like so, right, then the battery internal resistance will increase, okay, which causes the discharge capacity to decrease. Now, the internal resistance varies based on 3 factors. The first is the ohmic resistance, which is the resistance of electron conductors or the magnetic resistance, such as electrode grids and terminals. This increases when there is corrosions on the grid. The second type is called what we say the reaction resistance. Now, this manifests itself in the reaction between the active material and the electrolyte. And then the last one is called the diffusion resistance, where the charge transfer resistance is caused by too many or too few ions relative to the requirements of the battery reaction. Now, if the battery reaction progresses faster than diffusion can supply the ions, then there will be a shortage of ions near the electrode, so preventing the reaction. So when it comes to ACIR, there are 2 types. The first is the conductance method, and second type is the impedance method. Now, conductance method is basically what we say, what we call like inversing the resistance. Okay, As the name suggests, the lower the resistance, the better is the conductance, or the ability to allow electricity to flow through the battery. Okay, so that's the meaning of conductance. Now for this test, it is done during the discharge cycle under a controlled discharge current. Now this discharge current is normally very high. Okay, the conductance is calculated from the resulting changes in voltage, and this is done with the load disconnected. The drawback of such a testing method is that it is unmeasurable during charging. Okay, that's the only drawback. But other than that, it's still using Ohm's law to calculate on the resistance, but it's inversing the resistance to get the conductance. Okay, next we have what we call the impedance method. Now, Hyoki battery testers are using impedance method. Okay, and still same thing, we are still applying Ohm's law to it. Now, when it comes to impedance method, this test is conducted during charge and discharge, and also when the batteries are connected to the load. Okay, so again, for this testing method, it's very straightforward. We are applying a 1 kilohertz AC signal, injecting into the battery, and then the voltmeter will measure the voltage across it, and applying Ohm's law, R equals to V divided by I, to give the internal resistance while the load is connected. So it's important to note that this method is applicable during charge and discharge, and also when the load is connected. So most battery testers are using the impedance method right now. So if you ask, why do we need to inject a 1 kilohertz AC test signal? Okay, now, and why are we not using DC signal in that sense? Okay, because if you use DC, right, you can use a normal digital multimeter. Now, this is because using a 1 kilohertz AC signal, right, will excite the battery and allow the resistance to be measured. Now, if you're using DC signal, then the inherent electromotive force prevents correct measurements of resistance. And that is why, to eliminate this EMF effect, we have to use a AC 1 kilohertz signal. So through our research, we conducted that it is more practical and efficient to measure at 1 kilohertz because it is used for many AC low resistance meter, which are used in battery production line. In addition, the measurement current is low enough to avoid any kind of chemical reaction with the battery, yet high enough to withstand toughness against the noise that's applied to the charging signal.